Hey, I'm Mike. It's nice to meet you all. Thanks for having me here. Sorry to interrupt your lunch. This is the continuous visual integration talk. My co-founder Tim is in the back there. We have some Percy stickers for you throughout the talk, and yeah, thanks for having us. Really appreciate the opportunity to come down a couple blocks over and give the talk. So continuous visual integration, if you don't know what it is, you'll know what it is by the end of the talk. Don't worry about it, it's okay. And by the end, hopefully you all sort of have are inspired to do visual testing and to think about things in terms of visual testing, and you sort of understand the whole problem space and the things that go along with it. So I'm pretty freeform about this. I'm gonna rush through this really fast so that we can get to some questions at the end. There's a lot of info to cover, so shot of hot coffee. Right, here we go. So I'm Mike. I'm the co-founder of Percy.io, which is a platform for doing all the things that we're about to talk about. And yeah, this talk is going to come in about 3 different sections: an exploration of the problem space, visual diffs and perceptual diffs and how they can sort of help us to do visual testing, and then how we've architected Percy underneath with sort of really quick deep dive of what we've done to sort of address these problems of visual testing. So let's get started. So in general, who's heard visual regression testing, visual testing, any of those kinds of things, UI testing? Okay, cool, this will be great then. So the problem goes something like this. Unit testing is kind of a solved problem in a lot of ways. We have a lot of ways of testing the data of our systems and testing the functionality of our systems, and end-to-end testing our systems and smoke testing our deployments, and we've built grand machines of things to do continuous integration and continuous deployments, and we're getting to this point where we've automated all our testing and building procedures and all the deployments, and this is an example of a thing called Concourse CI, and they have this nice layout of how your continuous deployment pipeline is going, and we've built these grand machines, right? But how do you test something like this? So the button text is gone, or the button text is the same color as the button, or something's happened to this. And of course this was fixed by file and Asana task, right? Or here's another example. This is a 404 page of an app I used to work on. This is what it's supposed to look like. And it's just supposed to be sort of gimmicky and we've entered unknown space, that kind of thing. So we launched a change, and 4 weeks later we were told that our 404 page looked like this, which of course you've all seen before, and you know exactly what happened. And so we fixed it, and we launched the fix, and the fix looked like this. And of course, because no one QAs the 404 page on mobile, right? That's just not something we're going to spend time doing. And then I went to pull slides for this months after this has happened, and I noticed that it looked like this. So I reported it to my old team, right? And we find that these visual regressions, they often happen in the same problem area over and over, and it's that kind of place that you're not often checking, or it's the login flow, or it's the forgot password flow, or there's going to be some visual regression that sort of haunts you over time, right? So we call this a regression, and this is particularly a form of visual regression, right? So let's go back to that example of this button that's sort of lost its text. Can we write a regression test for this? I'm a big TDD, testing advocate. I like testing at the right layers at the right times, those kinds of things. So my first approach to this would be, okay, I want to go write a regression test for this so that thing never comes back, right? A regression test is the test you forgot to write in the first place. So let's go and write a test for this. This is an Ember test suite and an Ember acceptance test suite, but it sort of looks similar to a Ruby Capybara test suite or any sort of Selenium test. They all sort of follow the same kind of pattern where it's visit a page, fill in some information, click a button, and then assert something, right? Have some sort of expectation about what is the state of the page supposed to be. So there's a problem here, right? This doesn't break. The button still technically works. It's just visually wrong, right? So what am I supposed to do here to turn this into a regression test for that kind of failure? Am I supposed to check that some class exists on it, or that maybe the CSS computed style of the thing is correct, or that the color is a particular color, right? But then that's of course really fragile. So I'm probably just not going to do this, right? Or I'm going to do something assert that it has some class. And then, you assert that it has some class, but that's not really testing the visual side of it, right? That's, you could, like, CSS class could be overridden for that particular page in that particular place. So usually we sort of go down one of these two paths. We either just don't do it because it's easier to just fix the problem and move on, or we start writing these kinds of tests. So here's a real world example of writing these kinds of tests. This was from an app I used to work on. These were the tests we ended up writing, right? So good. And like really not fragile at all. It's like assert that it doesn't have a class, and then assert that the icon alert is there, and assert all these like text things are on the page, right? And so maybe if this is like a critical path, and it's really important that we test this one this way, so maybe we deal with like writing the tests for this one this way. But then that's, of course, not how it happens, because we develop a culture of testing things this way, and engineers start copying and pasting the tests, and so eventually we write more of this. Here's the expanded view of that page, and that's not actually it. Here's the expanded view of that page. And then we just keep doing this, right? We just keep doing this and just keep doing this and that. And then all of a sudden, we end up with like a test suite full of these really fragile, really flaky tests, or none at all, right? Those are kind of the worlds that we exist in right now. So, nope. The nope octopus says nope. So how do we actually test this stuff today, right? How are we actually like mitigating this risk of launching these kinds of things? And the answer is QA, right? So, and this could be, you're doing developer level QA, you're QAing things as you go out, maybe you have a QA team. I'm not sort of like setting a definition for QA, just saying we sort of fix the risk of launching these things with QA, right? And we all sort of know that QA is really complicated and it's slow and it's manual and it's expensive, but you kind of have to do it. And you have to keep checking these things because, maybe you don't care initially, maybe just ship it and it's okay if your customers send it to you. But eventually the risk of launching those kinds of changes is going to grow to, some huge level. And then you're going to have to be testing these things and mitigating that risk, and it's going to slow you down. It's also impossible to catch everything with manual QA, right? The examples I'm showing are like, it's a medium-sized app. It's not really what I would consider even like a large engineering project. It has maybe 60 models and like, a couple hundred different flows, but then that expands into thousands of possible page states and permutations and ways of getting into those page states. And this is in a developing app, right? It's something it's continuing, and that adds up really quickly. So the problem in general and the problem space is basically that pixels are changing, but we're often only testing the abstractions underneath those pixels, right? We're only testing what's underneath. And to go a little bit further than that, even with all of our current testing strategies and methodologies, we still lack confidence in our deploys, in the visual side of our deploys, right? You can have 1 million unit tests for all of the like data changes that you want in the world, but if you move a CSS file, you're gonna have to go look at it, right? So this is like one of the last parts of the CI/CD pipeline that we haven't really automated that well yet. So this boils down to a couple of questions. How can we know what pixels are changing? And because of that, how can we gain visual confidence in the changes that we're making? So that's sort of an exploration of the problem space. And I see a lot of nodding heads, so I feel like you're very familiar with this. You felt the pain of this. So that's good. So then we're going to sort of attempt to solve this problem with a thing called visual diffs. And to introduce these, does anybody know what a visual diff is? Perceptual diff? Okay, a couple of people. So they're called a lot of different things. They're called perceptual diffs, they're called visual diffs, or P diffs, or CSS diffs, or UI diffs, or visual regression testing. We just, we haven't come up with a converged on a name for them yet. But I call them visual diffs. And they look something like this. So given two images, what's the difference between these two images? And not just like looking at it, like what computationally is the difference between these two images? And that could be this, right? So all the red pixels that you see are the pixels that have changed between these two images without any context about what the images are about, right? You can do this for a photograph or whatever. That's just, it catches things like the drop shadow has changed and the things have changed. So that's a visual diff. Here's an example of a visual diff across these two pages. So you can sort of spot the differences, but if I just show you the visual diff, immediately you can see all of them, right? So you can see things like, oh, this link disappeared. I can flip back and forth between these, like the button here disappeared. It disappeared here. That got capitalized, right? You can also see things like, oh, look, nothing in this table has changed. I can immediately sort of say, like, nothing in that table has changed without sifting through it. So it gives you this sort of like really quick surfacing of that kind of information, kind of just like a code diff does. So let's go do some visual diffs. Here's a demo of visual diffs in 30 seconds. So I have these two images here. new and old. And let's just open them up and look at them. And okay, so I can just click between them. They have some differences, but let's go do a pdiff and make a pdiff and see what happens. So I have the ImageMagick library installed in the command line utilities. So I can just use the ImageMagick compare tool, give it new and old, and store the result in diff.png. And if we open up diff.png, great. Hey, here's our first pdiff, right? And by default, it sort of overlays the images, and it does this translucency. You can pass a whole bunch of different command line flags that have it output different things to you, and maybe just output the red pixels and change, change flags and things. So there's a lot of different options for this, and it's pretty straightforward to actually make them. Here's a couple of examples of pdiffs in real life. So you may not be able to tell really quickly what's different between these two pages, but if you look at the pdiff, you're like, oh, look, something in the footer in the bottom has changed. And if I read this, it says, oh, do you agree to the terms of use, right? And the terms of use box is just gone. It's just disappeared from this page. And I love this because this is actually an example of a backend change manifesting as a front-end failure. So this is like a Rails form object that got into some weird state and no longer has that check mark box for, do you agree to the terms of use? And you probably can't submit that form anymore, right? So the visual side of it sort of manifests what's happening underneath as well if your systems are tied that way. Here's an example of a pdiff that's of a page that has an intentional visual change. So some new person was added to this list. And if I just look at this, then I can say oh, look, okay, so a couple of things were added, and I can flip between them and figure out okay, somebody was added and it reflowed down. And you sort of have to learn how to read a pdiff, right? Because they can be kind of noisy. Here's an example of a broken dependency. So you can't really see what the difference is here, but I'll read it to you. It says, if type of jQuery not equal undefined, then something, something. That's in the footer down there. And this happened because a gem was in a broken state, and they upgraded the gem, and the gem happened to be in a broken state, and injected a broken script into the bottom of the page. So their tests were probably passing, right? But their footer has some junk in it. So it's kind of interesting to see that these kinds of visual diffs can call that out for you, because without it, you'd have to look at that page, you'd have to scroll to the footer, and you'd have to remember what it looked like before, right? Here's some pdiff art. Totally useless to you, but kind of cool. So this was just an image got shifted over just a perfect amount, and it showed up in our diffs, and I was like, oh, that's kind of cool. And also, just to sort of round out pdiffs, I think a 0-pixel pdiff is actually a really important signal for you. So a 0-pixel pdiff tells you with confidence, this page has not changed visually, right? And as your app grows and grows and grows, that's kind of what we're actually talking about when we're talking about confidence. We're talking about being able to say, I've only affected the things I meant to affect, right? I'm not unintentionally making a visual change across some set of pages or UI states that I didn't mean to. So actually having a 0-pixel pdiff is a really strong signal for this kind of testing. So simple uses, of course, catching visual regressions, right? But also, I've seen a bunch of advanced uses of this stuff sort of pop up. It makes a lot of sense. So CSS refactors and deletions is a big one. You're all terrified to delete CSS, yes or no? Right? It's terrifying, and we're inventing all of these things to modularize CSS and BEM and suit CSS, and we're trying to get it out of this one big global namespace. But it's one big global namespace. So, go add visual test the top 40 pages that you care about, then go delete some CSS and see what happens. If they didn't change, then you're probably safe to delete that CSS, right? So it can give you a really high confidence of knowing that deleting the CSS is okay. And then a bunch of other things, right? So testing style guides is a big one. Upgrading dependencies and just sort of knowing that they get upgraded. I actually love the combination of tools like Greenkeeper that they just upgrade dependencies when a new version comes out, and then it'll merge the PR for you without any intervention if your tests pass. So if you add that with visual testing, then all of a sudden you have the confidence that your unit tests have passed and your visual side of your app is not being affected by that dependency upgrade, right? Automatically without you even doing anything. So that's kind of a really cool use case. Visual regression testing for emails, because emails are very hard to QA. And testing visualizations is a big one too. You can write tests for things like D3, but you're usually just testing the inputs and the outputs, right? But what you really care about is the visualization. You care about what it looks like. So if you add some visual tests for the different states of the visualization that you like, then you can go fiddle with the very spaghetti-like tests of the data for a D3 visualization, when really what you care about is the pixels of it. So that's visual diffs. We're done. You can go home. What's the big deal, right? Why aren't we all doing this right now? It's so easy. So the rest of the exploration of this will be about what are all the other problems that come along with this kind of testing. And then in the Percy architecture section, we'll talk about like how we've attempted to address these problems. So I like bucketing the problems in these three general buckets: tooling and workflows, performance, and non-deterministic rendering. And we'll walk through each of these with a couple of examples. So tooling and workflows. This is a big one. I think there's a lot of questions with this kind of workflow, like where do I hold the images? Like what's the baseline? What am I comparing against? Where am I storing the things? How do I approve changes, right? And a lot of the open source apps will do things like, they're just libraries, so they'll just be like, okay, you just version the images into your Git repository. That's like a huge workflow process that I don't really want to do, so I'm probably not going to do it, right? So there's a big sort of like tooling and workflow problem that exists in the space. And then performance. I think performance is like, this is the big one across all the open source apps, all the proprietary apps, all the visual testing, everything. This is the big one that sort of keeps us from doing this for every app right now, because performance is actually a huge consideration in this world. And here I'll give you an example for this. So we have some images in Percy that we render every day that are 30,000, 40,000, 50,000 pixels high. And rendering those kinds of pages and diffing them and storing the images and doing the comparisons can take 20 seconds, to do all of those things. So if you have 100 UI states that you want to test, which is not that many, and you're doing this all serially at like 20 seconds, that's 2,000 seconds. And okay, like what is that in real time? That's 30 minutes you're adding to your test suite. And nobody wants to do that, right? Of course, if you're doing things like, we want our test suite to only ever be under 10 minutes or 5 minutes or whatever, you just can't have both of those worlds exist. So especially if you're doing things serially with this kind of rendering, it's just very slow. And it's not very slow because of any sort of inherent issue. It's that browsers are really complex, right? Like browsers are some of the most complex engineering projects we have nowadays, and rendering pages from across the web with all the resources and assets that you're loading into them it's a complex problem. So that's I think one of the big reasons why we're not doing this. And then non-deterministic rendering, which we'll go through a couple of examples. So the big one, of course, you probably already thought of, is animations. So like take this pure CSS animation on the left here. If I diff this, if I get a perceptual diff or a visual diff of this, which one am I going to get, right? Is it this one? Is it this one? Is it this one? Like, they're kind of just noise to you, right? Like, I can tell that's the same, that's working correctly, but a visual diff can't. So for example, in Percy, what we do to do this is we inject a bunch of really aggressive CSS styles into our rendering environment to try to freeze animations, so that then we can present you with a thing that says okay, no pixels have changed on this, right? It basically tries to freeze it at the first frame of the animation. And we do things like turn off animated GIFs, like that kind of stuff. And if you want to know more about that, we have a blog post on blog.percy.io about how we do that kind of animation freezing. Dynamic data is a big problem. So if you have anything that's time dependent on the page, of course that's going to be an issue, right? So the way that this is often addressed is as you move down the visual testing trail, you have to probably be embracing more fixture data and more mock data rather than fake or random data, that kind of thing. So yeah, dates are a big problem. There's a bunch of ways to work around this. You can freeze time, both in Ruby and JavaScript. It's pretty easy now to do that. So there's some ways you can work around this, but it's something that always comes up with visual testing. And then a bunch of problems that you may not anticipate also, like something underneath the test suites that we're actually running, the browsers we're actually running underneath, are not often modern in any sense of the word, right? This is Capybara WebKit on the left side, and this is what Firefox would render on the right. And you can see, yeah, the web font doesn't work, and the border image doesn't work over here. And same thing sort of exists with PhantomJS 1.9 before the recent 2.0 release. Phantom 1.9 was a fork of Chrome 14, from 7 years ago or whatever. It doesn't render the modern web. So it doesn't understand these floats here. It doesn't understand the web font. It doesn't understand background image. So if you write this in sort of a okay, I'm running a test suite browser and I just am capturing screenshots out of it, the screenshots you're going to get are often not representative of what the actual website looks like. So these old test browsers are actually a big problem because they're just often forks of a huge code base, and then they're sort of maintained for just that purpose. But we haven't used them for visual testing before. Or other things you wouldn't anticipate. So like a bug we hit with Percy was a customer contacted us and said, hey, sometimes the hover state on this button was triggered and sometimes it wasn't. And it's like creating a false positive. I was like, what could that possibly be? And so if you guys are running like tests in Circle CI and you're using like Chrome in there, it uses a virtual frame buffer, a thing called XVFB, which is like the most slimmed down version of a Linux windowing system you can get. We use the same like XVFB to run the browsers that we're running through Percy. And what happened was, as the browser windows would overlay, there's actually a mouse cursor inside of the XVFB environment, and it's in the middle of the screen. And if the button happened to exist in the middle of the screen and the window happened to be in the foreground, it might trigger the hover state, right? So I made this, I was like, to validate this, I created this thing that you see here, which is just a whole bunch of divs which react green to hover and red to active. And I just pushed it up to Percy a bunch of times and said like, okay, is this a problem? And sure enough, like a bunch of, 1 out of every 10 would have a little green box on it. So what's the fix for this? Shout it out. Move the cursor to 0, 0. Okay, yep. So we do that on every diff now. Just move the cursor to 0, 0. So yeah, and a bunch of other problems, like non-deterministic rendering is actually a big problem. GPUs don't actually guarantee that floating point operations are deterministic. So like if you divide a number on a certain GPU and you divide that number on another GPU, it may not be the same. If you compile your software with different optimization flags and you render it on the same GPU, it may not be the same. If you take a gradient on one machine and you render that same gradient on another machine, it may not be the same if these are GPU rendered graphics. So, but that's fine for games. It's not great for visual testing. And other things like, fonts are anti-aliased and have different anti-aliasings based on, the fonts and the OS. And, this becomes a really, like a sub-pixel problem at some point. So yeah, that's another reason. So PDIFs are only half the battle in this realm. So back to our original questions of how do we know what pixels are changing and how do we gain visual confidence in our changes? So I started thinking about this and got to a point where I was like, okay, so what are we doing for code right now? Like, what if I just replace this sort of idea with like, how do we know what code is changing and how are we getting confidence in like the quality of our code changes? And one answer to that is just code review, right? We're doing code review all the time, hopefully, because it gives us value that's outside of things like static analysis tools or linters can give us, right? It gives you context of the business that you're in. I can say in a code review, like, no, you don't need to build that thing. We've got this other system now, or whatever. Like things that don't exist within the realm of just a linter. So we find a lot of value out of this kind of feedback, right? And we find a lot of value out of having that sort of iterative workflow with our teammates. Visual reviews, that's sort of the next question. So that's how I've completely started to stop thinking about this in terms of like test failures, because that's a really sort of annoying world. It's like, oh, I have 100 test failures and they're just visual diffs of like I added something to the page, right? But if you think about this as like a visual review workflow, then it really becomes like part of a natural process. So the question becomes for me, like, how can we make visual reviews be as easy as code reviews, or as iterative as code reviews are? And this is what I mean when I say continuous visual integration. It's as much of a like philosophy of how you're doing stuff as it is like the set of tooling that sort of exists in this ecosystem. So continuous visual integration requires that the tooling has to be really fast. It has to be as fast as your test suite. You can't be waiting an hour for this kind of feedback. It needs to exist in sort of an iterative workflow. It has to be really early and really often, just like code review, and staging's way too late, right? Because the developer who's written that code that's already merged in has lost context for what it is. They don't want to go back and fix it. Staging's too late for me. And it has to be able to handle complex UI states, right? We're not just here to test our like static flat marketing pages. We need to be able to test all the different parts of our complex apps as they grow. So yeah, that's the sort of space of visual diffs. And then the last 10 minutes of this talk, I'll sort of show you a really quick in-depth dive of the architecture that we've built in Percy to sort of address these kinds of problems. So yeah. So Percy is a visual testing platform, and here's a sort of the demo that I like giving is not showing you Percy directly, but showing you like how you might encounter this in your development workflow. So here I have running the actual development version of Travis CI. Their entire front end is open source, and it's like a big app. So I like giving a demo of here just to sort of show you like, oh, you can click around it. It talks to their production APIs. It's like a real application, not some just contrived page. So let's say I'm like a new developer on the team, and I've been given the task to like, okay, go change this button color to blue. So everyone in this room could do this. You just go find the thing. It's called off button, right? And okay, I go find it and I look at off button. And I'm like, okay, great. Its background color is turf green. But let's say I don't really understand what's going to happen here. So I like go find turf green, and then I'm like, oh, I'll just change turf green to blue. So that's, of course, it's going to have a bunch of unanticipated side effects, but you don't know what they are. And if this is slightly contrived, but you can imagine a bunch of scenarios where you've done this and you didn't know you were going to affect that page, right? So if I go and I just push that change up to GitHub like I usually would, I'll walk you through the process here. So here's like the pull request. And I can just create the pull request. I'm like, yeah, that's the change I made. Great. Change button color. And then my CI suite will run. I'll get a little green check mark that says your tests have passed. And then Percy adds a little notation to your CI or to your GitHub pull request also that says, hey, 15 visual diffs need review. And so that's nice, right? Because then you've got like two things. You have like your tests have functionally passed, but hey, there's a bunch of visual changes you might want to look at as part of this change. So then you can just click details, and that drops you right over to the actual Percy experience for that build. And what we do is we just show all of the diffs side by side. So we use these visual diffs and we show them, and I can just scroll through them. And of course, you know what's coming. Like it's affected a whole bunch of pages that I didn't anticipate and a whole bunch of states. And I can just click this on the right to see underneath and sort of figure out like what's changed. And it's changed, it's changed this button, but of course it's changed this state here of this component. It's changed the home page, right? Here's the home page call to action that I didn't know I was going to affect. It's going to change the homepage headers, and I can just really quickly scroll through these and get a really quick sense of like, okay, where am I going to be affecting this app? And then I like pointing out also that we handle these complex UI states. So like this one right here, you may not be able to see it, but it's a little red dot, and I can click it and I can see, oh, that's a drop-down. Like that's the drop-down state if I had to click something in that nav to see it, and they happen to use turf green in this button or in this button color. So yeah, and then we also have like an understanding of the web site or web app underneath this, so we can actually render these at different DOM breakpoints, at different breakpoint widths, and then actually just show you like what they look like on mobile too. So here's the same change, but on the home page. So here's like the button change, but as it would exist in mobile. So then if I go through and I sort of finish out this process, let's say, for example, like, okay, we're fine with this change. We actually want to change everything to blue. Like, what does the approval process look like? So as I'm looking at this, I'm like, okay, that looks good. I can just click approve, or any of the approvers, the reviewers can click approve. And then that sets the GitHub status to green after a while. So that gives you this sort of like visual review process that we're talking about, right? Like really iterative, really simple visual review process. So we're only scratching the surface here of like what we want to be able to do with this kind of interface too, because the whole goal here is surface all of this information to you as quickly as possible, right? Let you consume all of those visual states really, really quickly. And you can sort of do it now with like, this overview mode and see like, okay, here's all the pages in this like overview mode. But we want to do a lot more to like make that sort of visual review process really seamless. And then last set of slides just to sort of walk you through like what are we doing underneath that is maybe something you might not anticipate. So here's like an acceptance test suite for this Ember app. And it just visits a page and clicks a drop-down toggle like normal. So what are we adding here? What are we going to put here to do this? Is it this? I hope not. So what we've done is we add a little helper to Ember and to Rails and to these other feature acceptance test suites that just give you, say, a name. And we just capture the state at like homepage with dropdown. Like that's the state of this page. It's the homepage with dropdown. Capture that state. And then we send that up to Percy for rendering. So what are we actually sending up here? Are we sending up like the images of this test suite? And I say that with lots of question marks and like really sarcastically because of course that's going to come along with all the problems that we mentioned before, right? You're going to push all the performance down into your test suite. So we can't do that. What we actually send up here is DOM snapshots, just a capture of the UI state, just HTML basically. And if you think about this, this makes a lot of sense because the most lossless, the most efficient encoding format for your website is not an image of the website or a video of the website. It's the website. It's the DOM state that you've created. And the only thing you really need to be able to reconstruct the rendering of this page is that captured DOM state and a whole bunch of complexity around like the development assets. And then you can actually render it in your own rendering environment. And you don't have to replay any of the network requests. You don't have to do any of the like test setup of like the mock data or whatever. The tests have actually already created that state. You've spent a lot of time getting these tests into the right state. Right? So you can then take this and just sort of leverage that and get visual testing out of it rather than that sort of like fragile expectation workflow. And just a little bit in the weeds for a second, so we actually don't send up DOM snapshots, we send up SHA-256 fingerprinted DOM snapshots and assets, which means we only ever upload everything once. So like if your development assets change, we only will ever upload the changed development assets, which makes everything really fast. So we send that stuff up to Percy. We can read a bunch of environment variables from your CI suites, like what commit information and metadata that we might want to display in the UI. We can push that status out to GitHub, and then a little bit into the, like, what is Percy doing underneath. We can push that stuff into storage. We can coordinate the work with like this Redis queue. And then we've built this custom rendering environment we call Percy Worker, which is it's containerized, and we pin like fonts and all the dependencies of the system so that we don't accidentally upgrade like the fonts of the system that might cause visual changes. We proxy all of your assets to like this development or to the storage so that we don't accidentally upgrade like the fonts of the system that might cause visual changes. We proxy all of your assets to like this development or to the storage environment, so you can send up things that aren't in production at all. You can just send up whatever your CI suite sent up to us. And then key point, like if you only take away one thing from like what I'm telling you about the architecture of Percy, it's this next one. We can parallelize it. So you sent us up these really cheap DOM snapshots that are just basically HTML. So if the rendering is the like computationally expensive part of doing this, then all we have to do is just parallelize that part of it. And it's completely out of band of your CI suite, right? So that gives us this huge architectural advantage of not being like forcing the performance concerns down into your environment, and we get control over the rendering environment, so we can do those things I was talking about, like turn off animated GIFs and freeze animations and make it really like a visual testing renderer. So that's the sort of underlying architecture of how we've attempted to solve these problems. And it sort of works pretty well in terms of like addressing these main concerns. So like we're integrated into GitHub PR workflows. The performance is basically as fast as you want because it's completely a concern of like how much concurrency we assign to it. And then non-deterministic rendering is kind of just like now our problem, right, and not your problem. So last slide, does this work? I'm happy to say yes. We've now rendered over 9 million visual diffs in Percy, which also means we've opened Firefox 9 million times and taken 9 million screenshots. And that actually adds up pretty fast. They're not small jobs to do, so that's like 50,000 CPU hours of rendering, which is like 6 years of rendering if you were to do it all on a single core and at 100% for 6 years. So yeah, I just want to leave you with a couple of points. So continuous visual integration. It's possible. We should all be doing it. It's as much of a philosophy as it is like the tooling underneath it. And it should feel like an iterative code review process, right? I feel like this is the last step of the CI/CD pipeline that we haven't really totally automated yet, and is still causing a lot of manual work. And it should ultimately be a thing that adds deployment confidence to your workflows. If you go down this path, you should start with a breadth of visual coverage over depth. So favor breadth over depth. Don't go in like, oh, my favorite component, and add 19 visual tests for that, and then you realize that like you didn't actually really test your app at all. Just add one test to as many UI states as you possibly can, and then all of a sudden you've got a pretty good coverage, and you can tune it over time. And then if you go down this path, you will have to start embracing a philosophy of updating your test suite to prefer more fixture data. It makes your life a whole lot easier. You can do things like set a faker seed, for example, which will just automatically create the same fake data for the same iterations. So that kind of stuff can be really useful because we used to not care about that fake data because we weren't caring about the pixels, but now we kind of care about the pixels. That's it. You can find me on Twitter here, Percy there, and yeah, happy to take any of your questions. Yeah.
So can you do this locally? Like everything that you showed was in a like GitHub or pull request workflow. If I sit with my parent workstation, I have to run this and look for it today.
Yeah, so the question is, can you do this locally? Yeah, you can. Percy is a service, so you kind of have to look at it as the service. But you can just run the tests locally, and if you enable Percy locally, then it'll send up snapshots, and you can render them in Percy. We don't have a great workflow for that yet, but it does work. We're primarily built to be in a CI environment and be talking to pull requests, but it does work locally. Yeah.
To fill in some context around that question, you brought up the you were on. We consider that largely slow.
Yeah. Yep.
Again, live code review.
Yep.
And so that would be workflow that would be most interesting.
Yeah, so you could just, at the end of your pairing session when you're ready to sort of ship the feature, run a set of tests through Percy and make sure you're not missing anything, right? And then that could give you the same confidence as if you were running it through the CI environment, right? You're still pushing a pull request and getting CI information, or do you run the CI yourself?
Straight to master.
Straight to master?
Straight to master.
And do you push them? Do you run the test locally? Does everybody just run the test suite locally?
Some of them. I mean, different teams have different equilibrium depending on how they split up.
Right.
All have CI also.
Okay.
But the code review part of it is just part of the pairing sequence.
Yep.
So the analogous place would be running these tests frequently and looking at them together.
Yep, totally. I basically would just think of it as that you are the CI system, or you're running it locally. So yeah, hopefully it would work just the same. Yeah.
Yeah, so I think the difference here between how we typically view our CI stuff is here the visual diffs don't really distinguish between intentional changes and unintentional changes, which I guess the traditional automated tests don't really either. But because you're running them, they're relatively easy to run locally and quickly.
Yep.
Like you're able to say, oh, that test failed, but I know that that's because I intentionally changed that. Also, you maybe unintentionally or intentionally walked into a crazy bin here, but we also do test-driven development.
Yep.
So we are generally changing our tests before we're changing our code.
Yep.
So most of the changes that we see are unintentional changes instead of intentional changes.
Yep.
But and with visual diffs, without some creative Photoshop work, you couldn't really test drive visual changes. So that's a
yeah.
good idea.
I actually once did run, because I do TDD also, and I was running TDD with Percy enabled locally, which is, we don't enable it by default locally, but I had it enabled, and it just kept creating Percy builds, and I actually found it really awesome to just go review 100 different page states really quickly in Percy as I was doing TDD. But like you say, it's a little bit fragile because you're making changes that are maybe intentionally broken all the way until the end. So yeah, I think it can fit into that realm. And the more that we can sort of push some of this tooling locally and make it happen for just an iterative piece. I just want to test that one page over and over and over. Then we can support more of that stuff. But yeah.
Project. You spent a fair amount of time trying to get Percy to want to get it. And I think the main thing is you're very important pull requests.
Yeah.
There's not a good way to get information out of the visual diffs, like the percentage change or something throw a red flag and say, hey, this broke something.
Mm-hmm.
So that's some feedback. The work from next week, but it'll be here. Be nice to be able to integrate it with CI and pull down look at the red flags and things that broke from the last time it passed. To be able to just go in and kind of slap messages.
Yeah.
Versus sort of basic.
Yeah, that's good feedback. We hear a lot of that stuff, especially just get it more integrated into Slack and my normal development workflow, even outside of pull requests. So, yeah. We do show this, though I don't think it's super helpful right now. We do show the percentage change right here. So this is 1.46% of the pixels in this page have changed. And right. Yeah. You want to be able to just have it. Yeah. Okay. Sounds
Is
good.
there an API that surfaces this information?
We're-
Like curl a build to get the percentage change?
We can set you up with an API key if you would like one. That's actually, yeah, our long-term goal is have a platform for this stuff where you can sort of mix and match any of the pieces that you would want as your own API. Cool, yeah.
In this pull request workflow, as soon as you accept this pull request, you're basically saying that I'm also accepting the visual changes. This is now the gold master that now all future pull requests are going to be based against.
So
Next pull request is accepted.
yeah, so we just use master's test run as the latest baseline. So when you merge that pull request in and then master's CI suite runs, then that will update the baseline for future comparisons. So it may not be totally the same for you guys because it sounds like you go straight to master basically. But if you're doing like a pull request workflow where you're waiting for it there and you click approve, that just sets the pull request as green. But then when you merge that in, your CI suite and master is going to kick off and make sure master isn't broken. So at that point, the baseline will just get updated. Yeah. Cool. Anything else? Yeah.
Snapshots, are you able to do testing like on multiple browsers?
Yeah, we're starting to expand into that too. We definitely want to do cross-browser testing. It's kind of like, I think of it like you can get most of the benefits, like 90% of the benefits of visual testing with like one good modern browser, and it's a really nice addition to that to have like, okay, cross-browser visual testing on top of that. So yeah, we're working on that as well.
If you run it locally, what's the speed of it? Because since you do a lot of optimization, like through the CI pipeline, it's sort of asynchronous. So you can do that run then parallelized on your side, but if we're running it locally, what would be the speed of the test?
It should basically have no overhead, no impact on the speed of your tests, other than a handful of HTTP requests. The first time it runs, it might be a little bit slow because it's uploading the assets, but the second time and third time, it should be pretty fast.
And the results of it would be pretty quick as well.
It's dependent on like how much concurrency you have in Percy to render them. So if we have some people who are sending up 300 snapshots every build, and they build 50 to 100 times a day, and they have a large plan that allows them to have like a lot of workers, so that we can be rendering that stuff really quickly, and their tests take a couple of minutes. So usually I like to say, like, if you're doing a CI workflow that takes a couple of minutes, we will hopefully be done by the same time or right after your CI is done. A little bit. Cool, thanks. Me and Tim are around, and we have some Percy stickers for you if you would like any. Thanks for having us over.